Don't worry, you're not in the video if I'm recording. It's just me in front. So I'm the only one who has to be on the video. So we are going to look at reviewing some key terms that we hopefully have learned and or talked about in past math classes. Okay, so one of those terms that we should know is what the opposite of a number is. Okay, so if I ask you for the opposite of 5, what do you say? Negative 5. If I say the opposite of negative 7, what do you say? 7. 7. If I say the opposite of negative 2/3, what do you say?
2/3.
2/3. So what does the opposite tell us to do?
If it's positive, the negative side of it. If it's negative, the positive side.
Right, so we are changing the sign. Right, if it's negative, we're going to make it positive. If it's positive, we're going to make it negative. The biggest problem I have with students is the fraction. When I say it out loud, there's never a problem. If I say the opposite of negative 2/3, my students say positive 2/3. When they see it written, they confuse themselves and think, well, I should make the 2 positive and the 3 negative. Okay, but remember that negative sign just functions as one thing for the entire problem, no matter where it's written. So the opposite of this is still just positive 2/3. Okay, are we okay on that one? How about... I'm not going to give you the word yet. How do we read that?
Absolute.
That was part of it. There's another word that goes with it.
Value.
Absolute value. So this says the absolute value of negative 3. What does absolute value mean? What is the absolute value of negative 3?
3.
What's your name? Owen? 3? Okay, why is it 3, Owen?
It's just like there's no sign really associated with it. It's just like what it is.
Okay, so when a number doesn't have a sign associated with it, what sign is actually there? A positive. Okay, so absolute value says to make the number positive. Regardless of what the number is, make it positive. So if I say the absolute value of 7, what is the absolute value of 7? 7. So same thing, if I have a fraction, what is the absolute value of negative 2/3? Are we okay on that one? How do we read that?
4 to the second power.
4 squared or 4 to the second power. What does that tell us to do?
Multiply it by itself.
Multiply it by itself, which is really then 4 times 4. So we'll talk about this tomorrow, but how many times I've seen students who, if they have something like 4 to the 5th power in their calculator, like 4 times 4 times 4 times 4 times. You don't have to do that, so we'll talk about ways that we can get around that. Right? We've all done it before when we didn't know what else to do. How do we read this?
Square root of 16.
The square root of 16? What is the square root of 16?
4.
How do we know that the square root of 16 is 4? Because 4 times 4 is 16. Do we know that those are inverse operations of each other? Right? Addition will undo subtraction. Multiplication will undo division. an exponent of 2 and a square root will undo each other. Those are inverse operations. Saying okay so far, so good? We're doing okay? Okay, how about some of these words? What does sum mean? To add, right? It's our answer to addition. So this one is our addition. What does difference mean? Subtraction. It's our answer to a subtraction problem. What does quotient mean? Answer to division. A division. How do we write division these days? Is that the division sign we write? Not so much anymore. How do we really write division at this level? A fraction bar, right? So we'll see a fraction. What's product?
Multiplication.
We're going to talk a lot about those sort of options and how we write them when we come back from lunch. Okay? So we're going to take a pause here. The lunch bell's going to ring in just a minute. Add 2 more as well. So we said quotient, division, but is also a fraction. Right, we would use a fraction bar. The bell already rang. Put your phone away. This is going to be a long trimester for some of you. Okay, so what other symbols can we use for multiplication?
A dot.
A dot. What else? Parentheses. There's one more.
A star. Asterisk.
Right, multiplication is our weird one that sometimes we write nothing. 8x is 8 times x. There's just nothing there. Okay, so it's important to remember that sometimes if there's nothing, that's multiplication. It's a weird one, right? Can we change the order of multiplication? Yep. Can we change the order of addition?
Yes.
Yep. Can we change the order of subtraction?
No.
Nope. Can we change the order of division?
No.
Nope. How about more than? That is the tempting one to pick. The alligators, right? An inequality symbol. This is not an inequality symbol. What if I say 4 more than a number?
Plus 4.
That's addition, right? So 4, right? If I say 4 more than a number is 4 plus a number, or can I change the order of addition?
Yes.
Or a number plus 4. Okay, so what then is the inequality symbol? If this is addition, what is the inequality symbol? What is that? Can't be more than, because I already used more than. Greater than would still tell us to add.
Less than.
This needs an is. Is more than. Is greater than. Okay, if we do not see the word is, then we are talking about the operation. Probably not something we've really thought about, but once I say that, my students are all kind of like, oh yeah, right? If I wrote down this, how would you read this? X is greater than 4, you would say the is. So that is what's telling us that it's an inequality symbol. Okay? So here's always the tricky one. So if more than is addition, what is less than?
Subtraction.
Subtraction, which overall seems to be fine, but if I say 4 less than a number, what would I need to write?
X minus 4.
A number minus 4, because the word than really tells us to change the order. So one of the things I tend to learn with my students at this point is that we've been taught some things about word problems and story problems, but typically we've been taught in a way where we've just been told and we're supposed to memorize it. Right? If you see a story problem, you read it, you underline the important information, you circle the question, and if you don't know how to write down an equation, what does your teacher probably say to you? Like, read it again? Did you underline the important information? Like, yes, I did. I don't know what I'm supposed to write. Right? Like, I don't know. There are actual things in math that tell us. The word than tells us to change the order. Now, it feels natural at this point that if I say 4 less than a number, it feels natural for my students to write down x minus 4. But the reason why is that the word than tells us to change the order. It just so happens that with addition, the order doesn't matter. So if you forget to change the order there, you're kind of in luck. Okay, but you really should be changing the order for the word than. Hopefully we know the rest of our symbols. So what's this one then? Is less than. Please don't tell me that it's an alligator opening a certain way. Right? If you're not sure how to remember, less than opens the same direction as an L. Okay? Thumbs up, thumbs down. Are we saying these are terms we know so far? We're doing okay? We're just cruising right along? Perfect. How could we simplify this? Mason, what do you say?
Combine like terms.
What like terms?
Like 4x and 3x.
Okay, so how would you like to combine those, Mason?
Adding them together.
Why add?
Because they're both positive and there's a plus sign before 2x.
Okay, so does this sign affect this?
No.
No. Right? We always look what's directly in front of it. Is this a plus sign or is this a positive sign? Is it? Is it?
It's a sign.
It is a sign.
It's a plus.
What word is this? Are we sure it's not red?
Yes.
Yeah.
Positive.
Which one is it?
To read.
It's read.
It's a
Like,
word.
I read a book.
No, it's I read.
We need context to be able to tell. It is the exact same thing in math. Is this addition or is this a positive? Uh-huh. Yep, sure is. Because it's both of them.
Told you.
We read it differently based on what we have around it. This is a positive 2x. But if I'm combining like terms, it's a 4x plus 2x. Okay, and so that becomes a 6x. What else can I combine? Okay, I can combine this -7 and a -1. How do I want to combine -7 and -1? Okay, so I could change it to adding the opposite and think of it as a negative. I could say -7 plus -1. I could say -7 minus 1. Those are the same thing. And what is -7 minus 1? -8. So if I write down -8, is this a subtraction or is this a negative? Both. Because now, well, this is the number -8. This says 6x minus 8. Are we okay on that? Is that an equation or is that an expression? What's the difference?
Equations have equal signs.
Equations have equal signs. Equations are something that give us directions to solve. Right? We're wanting to solve for something. Expressions are statements without an equal sign. Okay, so if we have an equation, we have an equal sign. And if we have an expression, There is no equal sign. Now, there could be more letters or numbers or operations or whatever else floating around in there, right? But it is all based on the key fact of there being an equal sign or no equal sign. Opposites. So far, so good? Okay, here's the last one, and this is going to be important because we're going to do a lot with this tomorrow. So if you don't understand everything that I'm putting up here, or some people remember more than others, that's okay. We are going to dive into this deeper tomorrow because this is an important one. But it is something you should have learned before, so I want to kind of see where we're at. I'm going to put some words up here. I guess those other ones could be. If I just write that up here, I want you to tell me anything that you are thinking or that you know from what you see up here on the board. Uh-oh. Okay, Mitch, what do you say?
I mean, integers are just like any number that's like on a number line or like a number, positive or negative.
It does have some positive numbers. Okay, so you're telling me that you know that there are some types of numbers that fall in integers. Okay? There is a little bit more specifics to that, but it does include some positive and negatives. What else do we think we know by looking up here? Lucy, what do you say?
They include each other.
Oh, they do include each other, right? It's a progressively growing scale. What else do we know? What do you say, Kate?
Whole numbers, they're not like decimals or fractions.
There are no fractions and decimals when we're at whole numbers. Are there whole numbers up here and not, or are there fractions or decimals up here? Are there fractions or decimals here? Are there fractions or decimals here? No. Right? This is still no fractions or decimals. Anything else that we know of here? Okay, so it sounds like we kind of have a basic understanding that these are ways that we can group numbers and we can talk about numbers. Sounds like we've talked about the idea that these are number sets, but we might need to do some more on what specific numbers fall into the different sets. Does that sound right? We agree with that statement? What do you say, Kate?
Aren't real numbers, so like, isn't pi is either in real numbers or it's definitely not. I can't remember which.
Pi is a real number, okay, but I don't have up here the set of irrational numbers, which is where pi falls over here.
Okay.
And we'll talk more about it tomorrow, but real numbers include basically all of the numbers that you know at this moment in your life. Okay, if you continue on with math in like a year and a half, your teacher's gonna say, oh, just kidding. There's also imaginary numbers. And so real numbers and imaginary numbers are sort of those two separate groups. You're just not aware of I know, right? Math's super cool. You're just not aware of those numbers yet. Some of your faces are like, oh, that's not cool, Mrs. McKinney. Not cool at all. Anything else from what we went over up here that we need to talk about or look at? We said we're okay? Okay, so that's it.